Alright, so this is section 6.1b, and we're doing rational inequalities, and what we want to do is find critical values and then test them to see what numbers would make this inequality true. And you always got to keep everything in respect of this original problem. Okay, so I'm going to flip over to my whiteboard and work it out. So here's that problem. When I talk about critical values, we are looking for zeros and numbers that would make the denominator zero. So one of the critical values, let me zoom this in or focus this. Okay, so one of the numbers that would make the denominator zero, x minus 3 equals 0, and you saw we get x equals 3. So this is one of the critical values, and then from there I will set this whole thing equal to 0. Now the Hawk's system does it a little bit different, but I'm going to multiply by x minus 3. And you got to be careful because depending on what the value of x is, this sign would flip. But for all purposes, I'm just doing it to find the critical values. So I'm going to multiply by x minus 3 over here. So we will have negative 2x times x minus 3 is less than 4. I'm going to distribute, and I'm also going to subtract and move this 4 over. So I will have negative 2x squared plus 6x, and then I'm going to move this over. Minus 4 is less than 0. So this is what we get when we set everything equal to 0, and we're just going to use this to get critical values. So I'm going to factor this side. So I'm going to divide out a negative 2 first, and you have to do that if you're going to factor because you can't have a negative term up front. So that will leave us with x squared. This will be minus 3x, and this will be plus 2, and this is less than 0. Okay, so from here I'm looking for numbers that multiply to give me 2 and add to give me 3, and that would be 2 and 3. So we got 1 and 2 actually, 1 and 2. First sign is my bigger number, second sign tells me they're the same. So this is the factored form, and I'm using this to get the critical value. So if you set each of these terms equal to 0, we get x equals positive 1, and we get x equals positive 2. Okay, so now that I got all my critical values, 1, 2, and 3, I'm going to test and see where on the number line is this true. So here's what I got: 1, 2, and 3. So either we go from negative infinity to 1, or we go from 1 to 2, we go 2 to 3, or we go 3 to positive infinity, and we could have multiple parts. But what we need to do is pick 4 numbers to test. So left of 1, I'm going to pick 0 to test. Between 0 and 1, I'm going to test a half. Between 2 and 3, I'm going to test this actually needs to be 1.5, sorry. So I'm going to say 3 over 2. Between here, I'm going to test 2.5, which that will give me 5 over 2 as a fraction, and then past 3 I'm going to test 4. Now these numbers I'm going to plug into the original equation, because again, whenever I multiply, depending on if the number was negative or positive, the sign should have got flipped, and then there's another degree of difficulty trying to decide what to plug in there. But for all purposes, in this case I'm plugging in positive numbers, which two of them, well, this one and this one and this one, three of them would give me a negative, so that means I would need to be opposite signs, which makes things a little bit more difficult. So it's just better to focus on the original. So if I plug in a 0 here, I will have 0 on the left is less than, and we'll have 4 over negative 3. Is 0, and I have to ask myself, is 0 less than 4 over 3? 4 over negative 3, which is a negative number, and 0 is bigger than all negative numbers, so this part is false. Okay, so we will not be using that part of the interval. Okay. Now I'm going to plug in, we can just say 1.5. It might make things easier. On one side it's going to be easier, and this side it'll be easier just to look at the fraction. So I'm going to plug in 3/2 over here, and that will give me a negative 3, and I'm saying that that is less than, and we will have 4 over, I'll just say 1.5 minus 3, which will give us a negative 1/2. I guess I really need to do that. Negative 1/2, negative 1.5, so negative 3 over 2. I actually need to work that out. Flip, we get negative 8 over 3. So I got negative 3 less than negative 8 over 3. And 3 goes in there, 2.33. So negative 3 is less than negative 2.33. And, or that's 6 actually. 6 repeating. And yes, it is. Okay. So this part will be true. So between 1 and 2, we do want that section. Okay. I'm erasing and give myself some more space. Alright, now I'm going to try 5 over 2. So plugging in 5 over 2 here, that will give me a negative 5 is less than, and then 5 over 2 is 2.5. So on the bottom that would just give me a half. So I'll have 4 over a half, and it'll be negative. And when I evaluate 4 divided by negative a half, that will just give me a negative 8. So negative 5 is less than negative 8. That is what we're getting for this piece. And negative 5 is actually greater than negative 8. So this part is false. So we will not use between 2 and 3. Alright, and then lastly, we will try 4, which will be pretty easy to plug in. So plugging in a 4 will give me a negative 8 is less than 4 here will give me positive 1 divided by 4 divided by positive 1 is 4. So I'm getting negative 8 is less than 4, and that is true. So from 3 to infinity we do want, so the parts that were true were 1 to 2. So my answer is going to be 1 to 2. And then union, I have this other part from 3 to positive infinity. Okay, so this is going to be my interval that makes this inequality true. So I'm going to flip back over to Hawks and plug this in. So our interval was from 1 to 2, and then I use a keypad to get the union, and then we were from 3 to infinity.